Stabilator. The stabilator is a variable angle of incidence airfoil that enhances the handling qualities and longitudinal control of the aircraft. The automatic mode of operation positions the stabilator to the best angle of attack for existing flight conditions. The UH60M has a flight control computer to process signals from various sources to adjust the stabilator to the proper flight position. The primary function of the stabilator is the longitudinal control of the aircraft. To achieve this, the control of the stabilator is programmed to its optimum angle to provide the following functions, also known as scalp. Streamline or align stabilator to main rotor downwash in low speed flight to minimize nose up attitude resulting from downwash. 30 knots and below to minimize nose up attitude from the main rotor downwash on the stabilator. Collective coupling to minimize pitch attitude excursions due to collective inputs from the pilot. Collective position sensors detect pilot collective displacement and program the stabilator a corresponding amount to counteract the pitch changes. This coupling begins at 30 knots. Angle of incidence decrease with increased airspeed to improve static stability. Programs up with airspeed increase. Lateral side slip to pitch coupling to reduce susceptibility to gusts. This feature compensates for downwash on the stabilator and tail rotor efficiency. In forward flight, the downwash on the retreating side of the rotor system is weaker than the downwash on the advancing side. If a right side slip is entered, left pedal applied, the stabilator encounters increased downwash and the nose tends to pitch up. Therefore, the stabilator programs down slightly to prevent that nose up attitude. A right side slip condition also results in increased induced flow through the tail rotor and corresponding decrease in the amount of lift provided by the tail rotor. In a left side slip, right pedal applied, the stabilator is positioned in a reduced downwash area, causing the nose to pitch down. The stabilator programs trailing edge up to prevent the nose from pitching down. A left side slip condition also results in decreased induced flow through the tail rotor and a corresponding increase in the amount of lift provided by the tail rotor. Pitch rate feedback to improve dynamic stability. The rate of pitch attitude change of the helicopter is sensed and used to position the stabilator to help dampen pitch excursions during gusty wind conditions. A sudden pitch up due to gusty winds would cause the stabilator to be programmed trailing edge down a very small amount to induce a nose down pitch to dampen that initial reaction. Flight mission display system for the stabilator. The stabilator angular position is displayed in the upper left corner of the MFD primary flight display. It provides an angular indicator and a digital readout. The digital readout is displayed above the indicator and ranges from -10 up and 45 down. The stabilator symbology is white when the stabilator is in auto mode, yellow when in manual mode, and red when stabilator fail has occurred. The above features are provided via inputs to dual actuators, which positions the stabilator. In the event that a failure occurs that prevents one FCC from positioning its respective actuator, the system will revert from auto mode to limited auto mode. This failure of one actuator will cause the stab degraded advisory to appear and restrict total maximum movement of the stabilator to about 35 degrees. If failure occurs full down or about 30 degrees, if failure occurs full up, the stabilator actuators receive power from the number 1 DC essential bus through a circuit breaker marked number 1 stab power and the number 2 DC primary bus through a circuit breaker marked number 2 stab power. Since the number 1 DC essential bus is powered by the battery, it is possible to manually slew one actuator using battery only. If the stabilator is slewed up, regain automatic control by manually slewing the stabilator full down and then push auto control reset once. Stabilator center section is comprised of a lock pin, a micro switch, and a keeper. The stabilator lock pin cable contains switches that close when the stabilator is locked in the flight position. Closure of the switches completes the automatic power on reset signal path that initiates automatic mode. When the stabilator is not in locked condition, stab unlock caution will be displayed on the ICAS display.